Hello everyone, today we'll talk about the problem step-by-step directions from a binary tree node to another. We're given a binary tree, so a root of the binary tree, and we're also given the values of two nodes, start node and end node, and we want to take the shortest path from start node to end node and return that path, but return it in the form of directions. Those directions would be L if we have to descend to the left child of the current node, likewise for R and the right child, and of course U for going up to the parent node. So we have to say how to get from start node to end node. Whenever we have a tree, and the tree is of course an acyclic graph, and graph being acyclic, not having any cycles, means that between any two nodes there is a unique simple path, because two different simple paths would create a cycle. And if we have a unique simple path, then that would be the shortest path that we have to return. And the form of any shortest path is we start at the start node, we want to reach the end node. We may have to go up the tree. It's not necessary, but maybe we have to. And then after going up the tree, maybe to the very root, we have to go down the tree, maybe left, right, to reach the destination node. In particular, we never can go down, then up, then down, then up. And we cannot go down some and then go up to reach the destination node. More specifically, for any two nodes in a tree that's rooted, we have this thing that would be their lowest common ancestor. So that ancestor is somewhere within the tree. And the paths from this lowest common ancestor to both these nodes, the unique simple path between the ancestor and each one of those nodes, now those paths are disjoint when we look at edges. And what we can also see here is that those paths are just the path from root to the left one, from root to the right one. But this common part here, we want to exclude, because that's the path to their lowest common ancestor. So in order to find the shortest path in a tree between two nodes, this path will be starting from one node, going up to their lowest common ancestor, and then going down from the lowest common ancestor to the destination node. And we can implement that by first finding this ancestor and then creating the path. Since we only want to find this lowest common ancestor of two nodes, we can just do it by looking at the whole tree. There are of course faster algorithms that can answer queries about lowest common ancestor, but it's not necessary here. And the general idea would essentially be that we would have to calculate the depth of both the nodes, then take the deeper node and go up until it's at the depth of the shallower node. Now they are at the same depth, and now we can move from both of them one step up until they meet. So if this was the destination node, first we have to go up so that they are on the same depth. And now we go step by step, so 3 steps let's say, and at 4th step they reach the same node. That's the lowest common ancestor by definition. But in this problem we don't even have to explicitly find it. In my solution I instead do something like this. I write down the path that's required to go from root to a given node. And to do that I just have to find the node. We of course do this recursively, because the node can be either ourselves, in which case we found the node, or it can be in the left tree or the right tree, or it can be nowhere. So we return true or false whether or not we have found the node in the subtree, and also remember what decisions, left or right, we had to make along the way. Then I determine the path from root to the start node and from root to the end node. And what do we do with those two paths? Well, it's very simple. Their common prefix, and since those paths are reversed here, their common suffix, is this part that we want to exclude, that goes to the lowest common ancestor. So we just get rid of it for as long as the first step of the remaining path is the same. And then, to get our final path, we have to again start at start, go to the lowest common ancestor, and we go upwards for all the steps, and then go from the lowest common ancestor down to the destination node. So the final part is just going from lowest common ancestor to the destination node. And we know how to get from lowest common ancestor to the start node by going left or right and stepping downwards. And of course, for our situation, we don't care about those L's and R's because we want to go upwards from the start node. So we take the number of steps up that were required to go down from the lowest common ancestor to the start node, and then we append the path from lowest common ancestor to the destination node. We make a string of that, and that is our result.